South Africa's first micro-hydropower plant has been developed at Kwa-Madiba village in the Eastern Cape. The plant supplies electricity to about 50 households. The Department of Science and Innovation funded the pilot project through the Water Research Commission. The work was led by the University of Pretoria. To talk more about this, Water Research Commission Executive Manager Bhagwan joins me. Thank you for your time. Give us an insight into exactly what the engineering is, without being too technical, so that our viewers can understand what exactly this is and why it's such a special effort.
Mar, if you have water that is flowing and flowing throughout the year, you can harvest the energy that exists in the water and use that energy to drive a turbine. And, as you drive a turbine, which is a little wheel at high revolutions, you're able to harness that mechanical energy and convert that into electrical energy. So it's not a very new technology. It's been there for 100 years. We've just used, some of the smart tools that are available to allow micro-hydro to be packaged much more easier and made more accessible to poor remote communities as an alternative energy source that is green and that can get to these places very, very quickly.
Can you scale this, Jay? Can you scale this in a country that we know is water scarce in many parts?
Absolutely. The issue is that we've come from this paradigm that everything needs to be centralized and big, and that we need to have all these fancy big grids, etc. And the load shedding is a consequence of us not dealing with this, because you have to deal with a big problem. What we should be doing is try to decentralize and bring decentralized energy technologies to many of these areas, that we can then sustain them and deal with them. So you asked me about scaling up. This is an opportunity to stimulate the green economy at a local level where economic growth is needed.
But what about water scarcity?
Micro-hydro?
We constantly come up, you know that the Eastern Cape, we're talking about boreholes. Gift of the Givers is there trying to provide water for communities. Does this technology work for a country like ours, or am I mistaken?
Well, water scarcity generally is a man-made consequence. Water is available, and if you manage it properly, you can harvest this and make it a potential energy source. So what I'm saying is that there's many streams and rivers that we dam and we collect water, but we never put it into an energy potential, okay? And we have now demonstrated through this micro-hydro project where we've taken an existing river, we're using the base flow that we call it the base flow, and it's based on that in 100 years we've never seen this river run dry, and we use the base flow as the safety net in designing the system to ensure that there will be electricity available, without much consequences.
So, Jay, once you power these 50 houses, is there anything that they can't do that they would be able to do if they had power from Eskom, for example?
Well, look, the thing is that they're off the grid, they're independent. It's limited to what the design is. So at the moment, the 50 households, the turbine has been designed for a certain quantity of electricity, and it covers the basic elements of household requirements. Of course, if you start, a lot of economic activity in those villages, you have to scale the turbine systems up to produce more energy, but that's possible, okay? And it's something that can be modular, and you can add on and slowly grow as that economy grows.
And do you have support now to replicate this? Because, like you say, it's a really interesting project. Surely there is an opportunity to try and get this moving in other small communities of 50 villages at a time, because we need it in our country. Is that going to happen? Is that your next step?
Well, this is what we are trying to promote in a big way, that if we put 1,000 of these units out, it stimulates a whole rural economy, but it also stimulates a whole green economy, creates an industrialization process around local manufacturing of turbines, builds local capacity, employs the youth, and it has this stimulus where we then wean ourselves off, the other energy forms and have a clean energy in rural areas that virtually does not cost anything because it's there. All we're doing is harvesting it.
So what has to happen next in order for you to move the project forward and achieve the kind of vision you've just spoken about?
So, with the vision from the Department of Science and Innovation to take these technologies and demonstrate it, now the job is up to local government and municipalities to replicate this and scale it up. And that is where, the policy and the structures sit in terms of ensuring that we can drive this at a bigger scale. It's also the President's commissions need to see this as part of a broader economic drive, as well as a job creation drive, rather than looking at still these very centralized approaches around trying to get coal-fired energy in these areas when these opportunities do exist. So we should harness what is there in this demonstration and replicate it to the benefit of many poor remote rural villages in South Africa that can enjoy electricity that is more sustainable.
And over again, you've mentioned the applicability in rural settings. Does this ever have an application for larger cities that need it? Or is it stymied by the size of the turbines for example, Durban or Johannesburg or Cape Town?
Well, actually, we started these demonstrations in the urban areas. And what we demonstrated that in the transport of water through these huge networks in urban areas, there's always excess energy that is available, that is bled off without being used. So in the city of Tshwane, at many of the reservoirs, and we demonstrated at 3 of them, we put in a turbine before the water was fed into the reservoir and harvested all that energy that they release and turned that into electricity. Now we think through our studies in Tshwane that if this low-hanging fruit is tapped, they can produce easily about 200 kilowatts of electricity that they can offset, for their own needs in running the municipal water treatment plants and wastewater treatment plants. And that's a huge saving. And in the night, you can then transfer that electricity to run the street lighting, etc. And it's there, it's available. As long as water is flowing, there is an opportunity to harvest energy from several parts of a distribution system. And, we've already, like I said, shown many of these cases. Bloem Water in Bloemfontein, we put in a system there that produces something like about 130 kilowatts that supplies the electricity to the offices of the Bloem Water administration, and that is saving them close about 800,000 rand a year with a payback period of 3 years in that investment. So it is there, it's easy, it's not new, it's just, changing the way we do things.